Francesca will.
Francesca.
Yes, yes, yes. But during introduction, Fabio should be able to see Francesca because she will.
Yes.
Yeah, she will introduce him. Yeah.
Okay. Yes, that was the one I gave you for the 2 days. For all the presenters. The guests could use YouTube. They can actually also go on to
So again,
Zoom.
very warm welcome to all of you to the Second Wise workshop. Just a bit of the historical background. The first one was in Japan, and we had an excellent time last year, and we were very grateful to our guests from Japan who have supported us and come so far. We are equally grateful to all our international guests that have come far away to present your work so that we can benefit and grow the international community. We are also very grateful to all our funding bodies, in particular ERSA, supporting all these interesting courses that we had over the first 3 days, given by our colleagues from around the world. We learn a lot, and we wish that this will keep on going in the future. We make it happen. I'll give the floor now to Dave Liu from ERSA. He is going to give us some particular details about everything else. Thank you so much.
Morning, everyone. Ladies and gentlemen. Welcome to the second annual RISE workshop. And it's grateful to have you all here, and welcome to Pretoria and welcome to South Africa. Okay. This workshop represents a significant opportunity for us to come together and engage in meaningful discussions on macroeconomic regimes and their implications for modeling and policy making. We designed the program such that to facilitate collaboration, inspire new ideas, and foster connections that will drive our respective field forward. Aiming at enriching our understanding and advancing knowledge in RISE, rationality in regime switch environments. On behalf of the organizing committee, I would like to thank Junior for all he has done to make this workshop happen. Thank you, Junior. I assume everybody know him. As Lucia just mentioned, I would I would like also to express my gratitude to Economic Research Southern Africa for their or consistent support for workshops, conference, and trainings in our academic community. And special thanks also go to University of Pretoria, especially Lucia, who has done a lot of work in organizing this workshop. And like myself, I get the easiest tasks among committee members. And also thank you for writing this speech for me, Lucia. You see how easy my task is? Additionally, we appreciate the support of the South African Reserve Bank and the South African National Research Foundation. Okay. I would like also to thank friends from University of Waseda who have been promoting research in this particular area and who also host the very first annual RISE workshop. Welcome. Lastly, and most importantly, I would like to thank staff members from Economic Research Southern Africa and the University of Pretoria, and everyone who has worked tirelessly to make this workshop possible. Right. With that, I announce the second annual RISE workshop officially open. I wish you a productive and inspiring workshop ahead. I now invite Francisca Loria to come up and to chair the first session.
All right. Hello, and thanks for joining us for the virtual keynote, which is going to be by Fabio Canova on a paper entitled "Does the Transmission of Monetary Policy Shocks Change When Inflation is High?" co-authored with Fernando Perez Forero. As one of Fabio's former students, Junior gave me the honor to spend a few words to introduce his talk. As many of you know, Fabio has been extremely influential in our profession. Among others, he has improved our understanding of VARs and DSG models, and made several methodological contributions that have been appreciated and are still being used by economists all around the world. The reason his work has been so influential is that Fabio never lived in academic ivory towers, but instead engaged with the challenges faced by practitioners and central bankers when confronting statistical and economic models with the data, offering clear guidance as well as creative and feasible solutions. And throughout this all, he has distinguished himself for being always approachable, always kind, always humble. With his contagious passion and energy, he inspired a generation of students who still, like me, look up to him in admiration and gratitude for the time and attention he generously devoted to us all. Now, outside of economics, Fabio has lived 100 lives, shaped by his 1,000 passions and million dreams. As if degrees in piano and orchestra direction, cinema and TV production were not enough, he most recently wrote a collection of short stories which unfortunately could not be submitted to Econometrica, although I invite the journal to broaden its horizon. Driven by his love of the unknown, Fabio is also an avid traveler, collecting remote corners of the world and life-threatening situations, to the point that people familiar with his travel experiences often find themselves asking questions like, do I remember well that he got kidnapped in Venezuela? Or did he really smuggle himself into Tibet? His love for and discovery of the vast greatness and diversity of our planet and its people is what also nurtured his commitment to contributing to the improvement of the life of others, making himself no stranger to causes of social justice and to volunteering activities, among others in Moria's refugee camp on the island of Lesbos. I'll stop here and give the floor to Fabio to do what he excels at, taking us somewhere new. Take it away, Fabio, and thank you all.
Thanks very much for the nice introduction. I don't deserve all what is said, but let me move on. Since this is an economic workshop, I'm very happy that the organizer asked me to present this paper, as I think is relevant for policy and is also interesting for academics in general. I hope you can see my screen. Please confirm me.
Yes, we can see your screen.
Very well. So, as Francesca said, this is joint work with Fernando Perez Forero, who used to be a student of mine, now is heading the research department at the Banco Central de la Reserva de Perú. Looks like I'm stuck here. Sorry, it seems like I have a problem moving on. Okay, so it looks like I'm able to do it. Okay, so let me start with a brief motivation of what this work is about. So, as you all know, the last couple of years have witnessed a very high increase in inflation, which was unprecedented for at least 40 years in the developed world. For example, in the EU, the average inflation rate was about 10%, but there were countries such as Netherlands or Estonia, which had close or even above 20% inflation in 2022. And just to give you a background, also in the US, the inflation rate was about 7.5%. So clearly, this is very small compared to some developing country, but in the developed world, this was unprecedented, at least for the last 40 years. And of course, this caused quite a lot of headaches to policymakers around the world. Most of the research has been concentrated in trying to understand what are the causes of this increase in inflation, and in particular, whether we can attribute them to supply factor, for example, disruption of the supply chain due to the COVID, or disruption due to the Ukrainian war, or whether they are due to demand factor, for example, the expansionary fiscal policy that most of the developed government undertook after the COVID. Together with this question, there is another question which is, at least to me, quite important, which is, does the transmission of monetary policy changes when inflation is high? And in particular, is that true that monetary policy becomes less powerful in regulating the real economy when inflation is high? And if this is the case, should we think about designing policy action which can make central bank and monetary policy more effective in this new state? There is also an academic point of view, which I'm going to mention very briefly at this talk, which basically suggests that in period of high inflation, monetary policy should be less effective in controlling the real economy. I list here 3 theories which are relatively common in the literature, what I call menu cost, rational inattention, and slanted L, Phillips curve. In menu cost, when there is high inflation, firms tend to change prices more often. Therefore, monetary policy shock should have more effect on inflation than on real activity. In rational inattention model, pay agents pay more attention to inflation news when inflation is high than it is low. Therefore, there should be more persistent effect on inflation expectation and less effect on a real variable. And similarly, the slanted L theory suggests that higher inflation should be related to higher production cost. Therefore, monetary policy shock should have much lower effect on real activity and unemployment in this high inflation state. So theory at least suggests that in high inflation, things could be different. So what this paper is all about is basically trying to measure whether monetary policy transmission is different in high versus low inflation regime. And I'm going to focus in this paper on the US, not because the US is the center of the world, but because it is the most, we have data which allows us to do more than with other countries. I will try to identify two particular monetary policy shock of many which I could. I will call them conventional monetary policy shock and liquidity shock. The first one is simply a shock which, think about it as a shock to a Taylor rule, something that unexpectedly increased the nominal interest rate given standard reaction to output and inflation. The second one, which I call liquidity shock, are more in line with what people call unconventional monetary policy shock. These are shocks which basically twist the term structure of interest rate and alter the quantity of money available in the economy. So I will look at these transmission of these two shocks in high and low inflation regime, and I will draw implication also for theory of output inflation trade-off. There is a small methodological contribution here. We're going to use what is called the Bayesian threshold autoregressive model with stochastic volatility and volatility feedback, which allows us basically to estimate a nonlinear switching model. And there's going to be another small contribution, which is since we're going to use a Bayesian approach in the posterior sampler, we are going to modify the identification scheme in such a way to make it more efficient along the line of a previous paper, which we have written with Fernando. So let me give you the results. So we do find some difference in the transmission, but they are not the difference that I would have expected based on the theory that I have mentioned before. In particular, what I call conventional shocks seem to produce weaker peak effect, but more persistent dynamics in the high inflation regime. And it looks like the reason why this happened is because there is some kind of information in the low inflation regime, which is not present in the high inflation regime, which agents take into account. Liquidity shock in general are more expansionary in the short term in the high inflation regime. And again, they seem to provide information about the state of the economy, but this time in the high inflation regime. And these things will be very evident by the behavior of two variables, which we are going to use in the empirical model, which are the slope of the term structure and stock index. And if you put together these three effects, the effect of conventional shock, the effect of liquidity shock, and the effect of this informational shock, it looks like the evidence seems to be inconsistent with popular theory of monetary policy transmission. There is a large literature discussing some of the topic that we will talk about in this paper. For example, the threshold Bayesian vector autoregression has been used recently, as you can see there, by a number of people. The closest paper is by Gargiulo and al., which basically use very similar framework to analyze a similar question. They use a different identification scheme for shocks. There are many papers which deal with nonlinear vector autoregressive model. There are many papers which deal with the nonlinear effect of monetary policy. I think the most relevant literature here is the literature on signaling effect of monetary policy, which was started by this paper of Melosi about 7 years ago, and basically made very popular in academics by the work of Marek Jaroczynski and Miranda Agrippino, Enrico. So we basically fit into this literature in different way, and we try to bring together all these trends of literature. So let me start with some descriptive graphs. So this is a US inflation, and I'm going to start from 1960. We're going to use the longest possible sample that is available to us. And I'm plotting here 3 different inflation series, one based on the personal consumption expenditure, one based on personal consumption expenditure excluding food and energy, and the third one is gross domestic product implicit deflator. As you can see, they are highly correlated. The smallest correlation, bilateral correlation, is 0.96. So I'm going to take the first one, which is the red, the personal consumption expenditure, as our measure of inflation, and I'm not going to discuss the rest. What is this picture telling us? Well, you see it here at the end, that after basically 30, 40 years of low inflation, below 5%, inflation peaked again, and the peak is comparable to what happened in the 2 large inflation effect of the 70s, the first oil crisis and the second oil crisis. Second picture I would like to show you is the distribution of inflation rates. What you see is an histogram here with some statistics concerning the mean, the median, the skewness, the kurtosis, and the interquartile range. Depicted on top of the histogram, you see a normal distribution with the mean and the variance corresponding to the histogram. As you clearly see, this is not, inflation doesn't seem to be drawn from a normal distribution. In fact, the mean and the median do different. The skewness and the kurtosis are different from the one of the normal distribution. And without even testing for these things, you can see that the right tail of inflation is much longer than and thicker than the left tail. And one thing that I would like to mention is that there is the interquartile range of inflation is pretty small, indicating that there are a lot of observation around some mean value, which is in this case is about 0.3, but then there are other values which are on the tail of the distribution. So the idea would be basically, rather than trying to fit a normal distribution here, to fit a mixture of normal distribution, one centered around some standard value and one centered around exceptionally high value. Let me describe now the empirical model that we're going to use. So the empirical model is slightly more complicated than what you probably are used to because of nonlinearity and feedbacks. So S is going to be our indicator for inflation. When S is low, when inflation is low, S is 0. When inflation is high, S is 1. So inside the parentheses, you see the model, which the empirical model that is going to be estimated when S is 0, and sorry, where S is 1, and the second part you will see the empirical model, which is estimated when S is when the inflation rate when S is 1 instead. So notice that the coefficients across the specification differ. So C1 may be different than C2, beta 1 may be different than beta 2, gamma 1 from gamma 2, and omega 1 may be different from omega 2. Z is the vector of endogenous variable, as you can see, is relatively large, includes standard macro variable like output growth, inflation, unemployment rate, the federal funds rate, the slope of the yield curve, money growth, commodity prices, and stock prices growth. Lambda t here is the volatility index, which entered the specification. I will show you why this is important to be included. Basically, what it does, volatility may affect directly the level of the variable over and above what lags of the endogenous variable or the constant may do within each of the regime. And if you're familiar with this, this looks very much like what people do in finance with the Garch in the mean process. So the indicator S is equal to 1 if the inflation rate is less than some threshold P star, and the threshold P star is unknown, as if unknown also the delay D over which we're going to use as indicator of inflation. So this means that basically if inflation is below P star at T minus, say, 2, then this indicator will switch to S equal to 1. The covariance matrix of the shock has a standard stochastic volatility effect. So the HT is going to be the volatility matrix. A is going to be the matrix of contemporaneous effect. And we're going to parameterize A in this way to make it to make the estimation more efficient. And the volatility matrix H is going to be driven by a single time-varying process, lambda t, as you can see there, which is an autoregressive process in log with some mean, some autoregressive persistence f, and some covariance q. Okay, so the reason why we use one indicator only is convenience, but there has been work in the literature showing that this is basically sufficient to capture uncertainty effects on the effect of uncertainty on the endogenous variable of VR. Let me tell you again briefly how we identify the two shocks of interest. So conventional monetary policy shock are normalized on the nominal interest rate. So this is going to be an increase in the nominal interest rate, and it's going to be accompanied by a fall, by a non-increase in inflation, by a fall in the money growth, and contemporaneously we are assuming that economic activity, industrial production growth, and unemployment will not react. The liquidity shock, by definition, is a shock which increases money growth and will twist the term structure of the interest rate. In particular, it will make long-term interest rate increase more than short-term interest rate. We're going to restrict contemporaneously all the variable of interest to be equal to 0. So economic activity, inflation, and the nominal and the unemployment rate will be 0. And we also restrict the short-term interest rate to be equal to 0. Let me spend a minute here explaining why we do this. And we restrict it, as you see here, for 24 periods rather than just one period. Think about a shock which increases money growth. Then an increase in money growth will likely to increase inflation sometime in the future. And if the economy is run via Taylor rule, then the short-term interest rate will increase endogenously simply as a reaction to the increase in inflation. So on one side, monetary policy is expansionary on the long term, and on the short term, monetary policy is contractive. So to avoid this, we restrict over a 2-year period that the short-term interest rate will not react enough to the inflation that will be generated. You will see later on what happens if we break this, if I have time. Anyway, it doesn't make much difference if we restrict it for 6 to 36 periods here, and results are going to be practically identical. So as I said, this is a complicated model to estimate. It takes quite a lot of time on the computer. We're going to use Bayesian approach. We're going to try to construct the posterior distribution of all the parameters, including, as you see here, the threshold, the delay, and the parameter of the model. And we're going to use basically Bayes' theorem and with a Gibbs sampler and an adaptive metropolis to construct the posterior distribution of the object of interest. Let me move to the results, and let me start by showing you what would happen in a linear model. So no switching indicator, no nonlinear effects, only the stochastic volatility entering them. So this is a contractionary, conventional monetary policy shock, which, as I said, is normalized on the federal funds rate. So the federal funds rate increased persistently, and after about 3 years, it gets back to zero. Central line is the median effect. Dotted line here represent the 68% credible sets. So when federal funds rate increase, as you can see here, industrial production growth falls. It falls persistently, and the peak effect is about 10 months or 12 months after the shocks. The unemployment rate increased very persistently and settled up for about 5% higher for 36 period. Inflation does fall, but the effect on inflation, as you can see, is pretty limited. It lasts about 4 months at most. The money growth falls. That's the definition that we're going to use for these shocks. And as you can see here, both the slope of the yield curve and output growth and stock prices growth fall in response to the monetary policy shock. So this seems to be pretty much the conventional effect that you would like to have when you tighten monetary policy. You decrease economic activity, you contract inflation, even though it's not very strong effect, and you depress the stock market, and you increase short-term interest rate relative to long-term interest rate. The fact that commodity prices growth seems to be pretty much consistent with the story that industrial production growth fall. When I look at liquidity shocks, remember that liquidity shocks are normalized in terms of money growth. So they are expansionary money growth shocks. Well, these things decrease the slope of the term structure. Eventually, after an initial period, will increase industrial production, will decrease unemployment, and will increase inflation as expected. There's going to be a depressing effect on stock prices, the flight to security, and there's going to be an increase in commodity price growth, which is consistent with the effect on industrial production. So if you think about this, this seems to be, again, consistent with the idea of unconventional monetary policy shock, which are, if they are expansionary, they will tend to expand the real side of the economy, but they will have very effect on inflation, but it will take some time. Now, I would like you to take a look or notice the scale of these graphs. These are pretty small effect, especially if you compare it with the effect of the conventional shocks. So it looks like these kind of shocks are going to have quantitatively much smaller effect than standard shock on the variable of interest. So let me now move to the nonlinear model, and let me plot together with this PCE inflation, the regime indicator. So this regime indicator tells you when the inflation is high as perceived by our model. So as you can see, it seems to confirm conventional wisdom. So we have 2 periods in the 70s when inflation was high, and the COVID period, post-COVID period here. And these correspond exactly, as you can see here, to the 3 peaks that we have noticed in the inflation rate. There is nothing here in the middle, So just by staring at this picture, you can figure out that probably the threshold that we're going to try to find is going to be around 5%. Because in these 3 episodes, the inflation rate was about 5%. And indeed, the posterior distribution of the threshold parameter is centered around 5.3%. It's very tight. As you can see, the distribution is very concentrated. So it seems like there is very much, there's plenty of information that seems to be the right place. And in terms of delay, the delay parameter is also very tightly estimated. Basically, you need a delay of about 2 months before you switch regime. So you need to observe at least 2 months of high inflation to be consistently into the high inflation regime. I mentioned about the uncertainty indicator. Let me show you why the uncertainty indicator is important. So let me assume that there are no autoregressive coefficients in the model, and there is just this lambda t parameter which enter the model, empirical model. Then what you see here in black is the inflation rate, and in red is the predicted value of inflation based simply on the lambda t indicator. So as you can see, the lambda t indicator basically doesn't do anything in the low inflation regime, and in the high inflation regime, which are the 3 peaks that you notice here, basically capture about 2% of the inflation. So the interpretation of these uncertainty or indicator is basically what it's doing is trying to eliminate a bit of the outlier which these episodes basically produce and the distribution of inflation. If you don't use lambda t in the empirical model, most of the results that I'm going to show you will not become significant across regimes. So it's very important to have this indicator in the empirical model. And just to give you a sense of how the estimation works, let me just plot the posterior distribution of some contemporaneous parameter. I'm not going to name any of them. I just want you to look and notice, for example, that for alpha 8, the distribution of the across regime do differ quite a lot, while, for example, for the parameter alpha 4, the 2 distribution basically overlap, even though the one in the low inflation regime is more tightly specified. So there are a few examples like alpha 21, alpha 18, alpha 20, alpha 12, alpha 11, alpha 8, in which the 2 distributions seems to be sufficiently different to make you think that there are going to be some difference in the transmission of inflation of monetary policy shock in the 2 regimes. Let me skip this and let me just move to the transmission of monetary policy shock in the nonlinear model. So the blue line now represents the transmission in the low inflation regime, and the red line represents the transmission in the high inflation regime. As you can see here, the shock is normalized to be exactly the same in the 2 regimes, and the response of the federal funds rate is basically the same. Okay, so the difference that they are not due basically to the process that we feed into the federal funds rate. So as you can see here, in the low inflation regime, the response of industrial production growth is deeper, but it tends to go to 0 much faster. So same thing with the unemployment rate and with the inflation rate. All the other variables do not seem to be different, commodity prices and money growth. There is a larger effect on stock prices in the low inflation regime, but basically this is not very different qualitatively. The only variable where you can see some difference is the slope of the yield curve. In the high inflation in the low inflation regime, in the high inflation regime, 3 months nominal rate increase more than 10-year nominal rate. And you see the slope of the term structure falling. In the low inflation regime, the opposite occur. In other words, even though in the low inflation regime, the 3 months nominal interest rate increase, the 10-year yield on 10-year bonds increase even more and generates this path. So it seems like in the low inflation regime, agents perceive the monetary policy shock differently than, or at least agents working in bond markets perceive the yield, the shock to monetary policy differently. So what is it? Why is it that they perceive the shock differently? Our guess is that this is some kind of signaling effect. So when inflation is low and monetary policy is, there is a monetary policy shock, it reveals information about the future state of the economy. And to check for this possibility, we do two exercises. One is a standard counterfactual in which we force the slope of the yield curve to be the same in the two regimes. And the question we ask is then, would the response of output growth, inflation and unemployment be exactly the same in that case? The second thing is, if it is true that 10-year yield react more than 3 months yield in the low inflation state, then it must be that inflation expectation react more to conventional shock in the low inflation regime. So the question is there any evidence that this is the case? So this is the counterfactual. And as you can see here, we force the slope of the yield curve to be the same in the two regimes. Now the response of unemployment is the same. The response of inflation is the same. There is a slight difference in the response of industrial production growth. But as you can see, the credible sets overlap. So statistically, they are not different. So it seems like the difference in the three variables of interest, which are industrial production growth, unemployment, and inflation, in the two regimes seems to be due to the effect on the slope of the term structure. The second thing we did was to look at professional forecaster inflation expectation and take 10-year inflation expectation, and we plot the response of inflation expectation to conventional monetary policy shock. The idea, remember, was that they are supposed to respond more in the low state than in the high state if the signaling effect is what we observe. And indeed, as you can see here, the effect in the low state is higher than in the high state. It is significant, while in the high state is not significant. So there is evidence that at least temporarily, here we are talking about 3 months, 4 months only, inflation expectation, long-term inflation expectation seems to react more in the low inflation regime than the high inflation regime to conventional monetary policy shock. Let me now move to liquidity shock. So liquidity shock, again, are normalized on money growth. We are not able to force them to be exactly the same. There is less persistence in the high inflation state in monetary growth. However, as you can see, the slope of the term structure is similar in the two states. So the three variables of interest are again on top of here. You see that industrial production growth reacts much more strongly in the high inflation regime. There is some effect also on inflation, not much of an effect on unemployment. And here is the federal funds rate. As I told you, it was kept fixed for 24 period, and then after 24 period, basically, it doesn't react very much. So again, here, there are some differences in industrial production growth, there are some differences in inflation, but it seems like most of the variables seems to be not very different across regime, except, as you can see down here, stock prices. So in the high inflation regime, stock price growth is boosted by an increase in money growth, while in the low inflation regime, stock prices boost is negatively affected by the money growth. So it seems like in the low inflation regime, a potentially higher inflation is damaging for the stock market. In the high inflation regime, more inflation is probably a good news for the stock market. Notice that the increase in the stock market here is consistent with increase in industrial production. So we would like to know if this signaling effect, the fact that stock prices react in anticipation of industrial production, can be attributed to signaling effect again. So we run, as we have done before, a counterfactual, fixing the response of the stock price growth in the high inflation regime and checking if the responses of the other variable are the same. And we're going to look at a proxy for profitability, which is firm net entry in the market, to see if they react more in the high inflation regime than in the low inflation regime. So here is the counterfactual. We force this to be the same across regimes. And as you can see in the top row, then the responses of unemployment, inflation, and industrial production growth turned out to be the same. So the difference we have noticed before seems to be due indeed to this inversion of the response of the slope of the Standard & Poor's 500. Furthermore, I'm going to show you the dynamics of net entry in response to liquidity shock. And again, the idea was that in the high inflation regime, there's a higher profitability. Therefore, there are going to be high entry in the market. Now, the effect is not particularly strong, as you can see here, but at least after 4 months, there seems to be an increase in the net entry of the firms. While in the low inflation regime, there's basically no effect throughout the sample. So overall, it seems like there are signaling effects which go through the slope of the yield curve or stock markets, and which are appearing asymmetrically only in certain states, but not in others. So let me move to now talking about theories, how these results can be interpreted in terms of theory. Now, it turns out that the 3 theories I mentioned at the beginning, menu cost, rational inattention, and slanted L theory, can be translated into changes in the slope of the Phillips curve across regime. And all 3 of them simply tell you that the slope of the Phillips curve must be steeper in the high inflation regime. In particular, this is true for menu cost and rational inattention. To be precise, the slanted L tells you that the slope is steeper when the vacancy to unemployment ratio is high. It turns out that the vacancy unemployment ratio is high typically when inflation is high. And you see here a measure of the market tightness, the vacancy to unemployment ratio. So I'm going to try to see how the slope of the term structure reacts. The slope of the Phillips curve reacts to the shocks in the regimes. So here is the reaction of the slope of the Phillips curve when the slope of the Phillips curve is measured by the trade-off between the labor share and inflation. And as you can see here, if there is a reaction, it's typically larger in the low inflation regime than in the high inflation regime, as the theory would suggest. If instead of using the labor share, you're using, and in response to liquidity shock, you basically get no effects. It's basically similar across the regime. If instead of using the labor share, you're going to use the vacancy unemployment rate to measure the slope of the Phillips curve, you get again similar results. the response is going to be larger and more significant in the low state rather than in the high state, as theory predicts, and the same thing with liquidity shock. So it seems like neither menu cost nor rational inattention nor slanted L seems to be consistent with the dynamics that we uncovered. And in particular, with the fact that in low state, unconventional monetary policy shock tend to have a stronger effect on the yield curve, and in the high state, unconventional monetary policy shock seem to have a different effect on stock market. I already showed you the inflation expectation in response to conventional shock. And again, this is inconsistent with the rational inattention, and the response of the inflation expectation to liquidity shocks, as you can see, is basically the same across regimes. So to conclude, the paper has a number of robustness exercises, which are very complicated and time-consuming to be carried on. So, for example, we have eliminated the stochastic volatility from the time varying from the threshold VAR specification. If you do this, basically the difference I showed you across the regime disappeared. We have eliminated the 70 and the COVID period to see what would be the threshold in that case. And it turns out that the threshold is about 3.3%, and the distribution seems to be almost normal above and below. So it seems to be almost symmetric above and below. We estimated the 3-state models with the idea that in the sample there is a zero lower bound on interest rate. Maybe, and inflation was pretty low for a long time, maybe we should be able to capture with a 3rd state this very low inflation situation. Indeed, we do find that the low threshold is pretty low, it's about 1.5%, but in no way it's closer to zero. So these are the 3 thresholds in case use. Sorry, this is a 4-state, not a 3-state. So these are the 3 thresholds that you use in that case. We substituted the personal consumption expenditure inflation with the standard measure without food and energy, nothing changed. We substituted the commodity prices with oil prices, and the idea here is that the US is an oil producer, so it may have effect directly on oil production. We do eliminate the constraints on the short-term interest rate after liquidity shock, and if you do that, immediately the nominal interest rate jump, short-term nominal interest rate jumps. And the final result is that we study if there is size and sign nonlinearity in the model. We don't find very much. It's in the paper, so I'm not going to spend much time discussing it. So to conclude, I think there are 2 conclusions that I would like to emphasize, one for policymaker, one for academics. For policymaker, it seems like there is some difference in the transmission of monetary policy shock across the regime. The transmission is, however, has to do more with the signaling effect. So there are some regimes in which monetary policy is conveying information about private agent about the state of the economy, which private agent maybe forget about or do not consider before. And that's important, very important to be clear about what this signal is and how and what it refers. It turns out to be slightly different in terms of conventional and unconventional shocks. In one case, the bond markets seem to be reacting more. In the other case, stock market seems to react more. And in terms of academics, it seems like the standard model that nowadays are used to interpret the evidence, which are built, for example, in standard New Keynesian DSG model used both in academic and central banks, seems to be at odds with the transmission of monetary policy. And they are at odds for two reasons. One, because there are symmetric effects across regime, and two, because it seems to be that there are informational effects which are typically not modeled in these DSG framework. Thank you very much. I'm sorry, I don't hear very much.
I just said that we're going to open the floor for questions. So if anyone has a question for Fabio, just raise your hand and I'll bring the mic or, yeah.
Hi, Fabio, Gianni here. I have a couple of questions like you asked. I start from one. It seems that, I'm just concentrating to what happened basically with the most recent inflation bout. So it seems to me that one important role in the way in which the restrictive monetary policy is affecting the economy in the US is very strictly related to also what happened on the fiscal side. And so I was wondering whether your model has anything to say about that. So that's my first question. And my second question is the following. I really like the idea of having one scalar factor to drive volatility throughout all the sample, and I guess that this thing makes things very, kind of easier. I'm not really sure how does it work, especially when you take into consideration the high leverage sub-period, which is, kind of the COVID and the post-COVID sample, because there, you have some macro variables, in particular GDP and unemployment and also consumption that had really crazy swings, and I'm not really sure the effect that, having just one factor would impart on your assessment of volatility. Thanks.
Do we answer immediately or do we pick up questions?
I would say, yeah, answer immediately and then we just go through the room.
Okay, thanks, Gianni. And I think this both questions are well taken. We have nothing to say right now about fiscal policy, and it's obviously going to be very important to understand this. There's one thing that I want to mention, probably for people which are not familiar. So there was a fiscal episode here of large increase of government spending in the 80s. That was the Reagan supply side effect. As you can see here, inflation in the 80s was still going down, despite the fact that there was a huge increase in fiscal policy. While here, as we all know, the increase in fiscal policy was quite large and inflation went up. So I think, as Gianni said, I think needs to be investigated more. We don't have anything to say right now. We will do some sensitivity analysis or some more work on that part. Now, in terms of the unique indicator, volatility indicator, we were perfectly aware of the problem here, that it looks like at least post-2020, some financial variable and some real variable do not seem to move together in terms of volatility. Therefore, would make sense to have at least two indicators for volatility, maybe one for financial variable and one for real variable and inflation. We did try that, and it turned out that it just didn't make a huge difference. The only thing it did was to make standard error enormously large. So my guess was that probably what it's doing is simply there was some form of collinearity. But in other words, I'm not saying that this is not going to be important, but once you look in the perspective of 63 years of inflation data, the last few months of these volatility changes are not going to be particularly important across regime. As you can see here, This is the time series. This is the posterior distribution of the uncertainty indicator, the volatility indicator. And indeed, it's picking up quite a lot in the post-COVID period. Thank you.
Hi, it's Roberto De Santis. I have a small question here. First of all, concerning the number of observations in the high inflation regime, at least from the chart, it looked to me very, very small, something like 30, 40 observations. So I wonder if you can talk about it and how, if this has implications in the estimation of the Bayesian VAR. The second question is, you did not mention if the impulse response function take into consideration the fact that the regime can change, at horizon t plus h. If you can spend one word on this. And third, how you, I wonder if you could do some robustness using the high frequency monetary policy surprises. There is this debate now, it's very difficult to publish paper estimating monetary policy shock with some restrictions using aggregate macro. There is all this literature using high frequency. I wonder if you could do something. Obviously the sample would become smaller, but I wonder with a threshold bar, I think is still this feasible. Thank you.
Okay, thanks, Roberto. Now, all three, again, very good question. You don't have time or you don't think about talking about. So as you have probably noticed, given this picture, the high inflation regime has very small number of observation, as indeed they are roughly 36. So the model is quite complicated, 36 observation. There is small sample issues, definitely. However, in a Bayesian framework, the fact that you have 36 observation doesn't make any difference. The prior are the same across regimes. So the fact that we do find a significant effect in the high inflation regime, to me, is an indication that there is quite a lot of information, even in those 36 data points. But it's definitely true that this is a small sample. Now, second question concerned about the regime changes in the impulse response function. So typically in these exercises, what people do, they condition on the initial state. And they assume that the impulse responses stay in the same state. So if you do an impulse response in the low inflation regime, you're assuming basically that you stay in that regime throughout the impulse response horizon. That's not what we are doing. So at each point in time, there is a probability that you're going to switch in the other regime. So these are fully generalized impulse response function, where starting from initial regime, which is low or high, you can switch throughout the 36 months horizon that we plot there. Now that makes, in general, impulse responses less significant across regime, but I think that's the right way of doing things, because in the process, the regime may change. Now, the last question, I think it also is well taken. Why don't we use some standard measure of high-frequency monetary policy shock? The problem is that to do an instrumental variable threshold model, it's complicated at this point. So we haven't done it. But we have done some correlation. So one of the reasons why I plotted these things here, the posterior distribution of conventional shock, was because we did try to correlate over the sample period over which both are available, these measures with the standard monetary, high-frequency monetary policy surprises, and they're not that different. So the correlation is about 0.6, 0.7. So they're not exactly the same, but we are confident they are close enough. More than this, at this point, technically, we're not able to implement yet the instrumental variable approach here. Thank you.
I just want to give a comment on the results for liquidity shock. You showed us that stock market react to liquidity shock differently under a high inflation regime and a low inflation regime. In theory, one would expect a positive liquidity shock will cause stock market to increase, the Standard & Poor 500. It's just a matter of the magnitude of the increase. I was wondering if this is due to, we just discussed the sample, the number of observations for high inflation regime is really small over a sample period, and also during the zero lower bound period, you know, that will also play a role for the impact of the liquidity shock, which we can also interpret as unconventional monetary policy shock during zero lower bound. Perhaps to plot the series of the stock market index and M2 growth, and might help to understand the results better. Thank you.
I'm not sure I fully understand the question, but so I think I understand the first part. I think the main difference here is the change in sign. So in one state, in the high state, increase in money growth seemed to be good news for the stock market, while in the low state, increase in money growth seems to be bad news for the stock market. So it looks like if you think about stock market and looking forward, then it has to do with the way, you know, economic activity is going to develop in the future. In one case, in the high inflation state, industrial production seems to be going up much more than in a low inflation state. And the fact that we have this entry measure that basically seems to be consistent with this story, even though I have to admit this is a quarterly measure, is not a monthly measure, so things may be subject to aggregation bias here. In terms of plots, I have plots here of the various time series. So this is stock market growth. So I don't see much of a difference in the 70 versus the 80. There is quite a lot of volatility. There's quite a lot of changes, but I don't see a big difference in there. Thank you.
Thank you, Fabio. We have another question from our online audience. This is from Sergey. He asks, why do you use inflation as a threshold variable? Is it natural to expect that many variables, including unobserved ones, have effects on linearization of variable dependence, switching of regimes, or other thresholds? Then, why are low inflation regime responses much smoother than high ones? Thank you.
So let me start from the last one. They're not, I don't think they are smoother. In a way they are a little bit more, they are smoother, but I think this is exactly the result of small samples, the fact that we're not able really to measure here correctly because we don't have enough data points. Regarding the first question, I think it's obviously clear that you can have many variables affecting the threshold. We're simply focusing on inflation here because we want to, the task of this paper is about, high versus low inflation regime. So if we had an indicator variable, which was a linear combination of a number of variables, or there's going to be a number of variables which affect the threshold, then the interpretation of the results will be probably a little bit more complicated. I understand the point, and I think it's well taken. Thank you.
Hi, Fabio, and thank you for the slides. I wonder if there's a role of inflation targeting that might be at play in this model, or whether one can use your NICE model to test whether, you know, when the monetary authority in the US perhaps transitions from, you know, a more implicit inflation targeting regime, or you know, the transmission mechanisms that you discussed that get factored into inflationary expectations, whether, you know, across the two regimes when inflation is high or inflation is low, but the monetary authorities targets inflation more or less implicitly, how this affects agents' behaviors in the stock market or in the bonds market. I'm guessing there might be an effect that can, you know, can get affected into this story.
You're definitely correct.
Thank you.
You're definitely correct. I think there is that possibility. Our guess is that for the US, this what we call credibility effect may be small relative to what we think about. But if we would apply this model to Peru, for example, where my co-author is, or any other developed country, I think that will be probably first order magnitude of importance. So the rule that the central bank is following is going to be very important. We simply thought that for the US, this was not going to be crucial, but we definitely will investigate more along those lines. Thank you.
Question from me to Fabio. Over the last 3 days, we taught here a course, as you might know, on regime switching, DSGE models, regime switching, structural VAR models. So I assume that people that liked your talk and perhaps want to do something similar, applying it to perhaps South Africa or, you know, country of their choice, might want to replicate this, perhaps using regime switching VAR model. Now, if you could speak a bit to the differences between your approach and the regime switching VAR model, I think it might be useful to us in the audience. And you already spoke to the fact that obviously you use a threshold VAR where you want inflation to inform the state that governs the switch for a specific reason, because that's the question that you address. But given that is a technology that they now have access to, you know, might be worth spending a few words on that if you can. Thank you.
Well, I think this is another very well deserved question. Why this and not why the technology which is in REIS? Well, this was simply a choice of my co-author because he knew how to work with this, and it turned out to be a bad choice. I think the Markov switching VR will be easier to implement. This takes quite a lot of time, has a lot of technicality to be solved. But basically the idea, the difference between the two approaches, that here there's a hard threshold and I would say in a switching VR, there is a soft threshold. There's a probability of switching. Here, there's a kind of a step function, which, and the estimating model with step function has never been easy. I think it's, the Markov switching technology is probably much easier to implement. So if I have to suggest anybody to do a study like this, I would probably tell them to use the tools that you learn in these 3 days rather than getting into this, which require very large computer power, lots of patience, and a lot of trial and error.
Well, you confirm that all the things I said about you in the introduction are absolutely true. This speaks to your continuous intellectual honesty, and thanks for that, Fabio. Thanks for your talk. I think we all greatly enjoyed it. Maybe we all give a round of applause again to Fabio.
Thank you very much. I enjoyed very much the presentation and your questions.
All right, so we head for a break and then we join again for the next session.